So welcome to you all. My name is Liz
And I'm Charlie.
and we're members of the NRICH team. We're based in Cambridge. It's great to have so many of you here this afternoon. We would like to say a quick thank you to Trinity College here in Cambridge, who do fund these webinars so that you don't need to pay to participate. Perhaps you've been to one of our webinars before. That might be, maybe you're part of the Problem Solving Schools programme. Maybe you're here for the first time. It really doesn't matter, and you're all very, very welcome. What we are focusing on this afternoon is maths for all. If you're familiar with NRICH, you may well have heard the phrase low threshold, high ceiling before. Many of the tasks we offer on the NRICH website are what we call low threshold, high ceiling tasks, and we advocate a pedagogy associated with that to really make the most of those tasks. What we hope to do in this afternoon's session is to introduce you to a low threshold, high ceiling task and work with you on it. We're going to attempt to model the way that you could use your task with your own learners back at school. And once we'll be inviting you to contribute, your ideas about the mathematics and in the sense of you, the learner, via the chat. We'll leave some time to then unpick the key characteristics of the task and we'll reflect together on the kind of strategies that Charlie and I will hopefully demonstrate in order to get the most out of these kind of tasks. The recording for today's webinar will go on the NRICH website and we'll point you in the direction of the page where you'll find it towards the end. Charlie, have I introduced everything? Is there anything I have forgotten? This is a test whether Charlie's been listening.
I was checking that the recording was working, and it is.
Okay, good. Right, well, let's do some maths, shall we? Okay, I'm going to share the visualizer that we've got set up here. So, Charlie, I'm poking around in some of our cupboards at home. We've just had our kitchen floor redone, and because I love maths, I do keep some multi-link in that cupboard, and so here's some. You'll notice we've got two different colours of multi-link. I've got some sticks of two. If you're all right, if I call them a stick of two. Those are the red ones or the pinky coloured ones, and we've got some sticks of three, the blue ones. I kind of, some thoughts, some questions occur to me. If I start joining some of these sticks to make longer sticks, I guess, for example, I could join three of my sticks of two, and I think there I've got a stick of six, for example. That's one thing I could do. It occurs to me that actually I could make six using two blues. Do you know what? What I might do actually is separate those so that it's obvious they've come, a bit more obvious that I've come from, there we go. Okay, so I've got a six made from three of the red twos, and I've also got a six made from two of the blue sixes. So already, what I love about this really simple starting point is it's making me ask some questions. And I've shown that we can make six in these two ways. So a number of questions are coming to mind now. One of the questions might be, could I make six in any other way? So that's one question. Another question could be, well, what other numbers might I make with my twos and my threes? So
Yes, and are there always two different ways of
right.
making them?
That's another nice thing to throw in the mix. So actually, I'm not going to say any more. I would like to leave you a little bit of thinking time. You might decide to check whether there are any other ways of making six. If you think there are only two ways, are there always going to be two ways to make other numbers? What other numbers can you make? Have a little think. if you would please post your ideas in the chat, that would be really helpful. Um, it would help us if you could post not only the number that you've managed to make, but also how you've managed to make it, because that will help us begin to unpick some of these ideas. So just to recap, we've got twos and we've got threes. What numbers can we make by putting together twos and threes? Have we found all the ways to make six here?
Yes,
Over to
we're
you.
allowed a combination of two.
Yes, which occurs to me. I should have made that clear, shouldn't I? So there we go. We could make five as well because I could put a three and a two together. Okay, so over to you. Have a little go, post on the chat. We'll give you sort of 5 minutes to have a little go, and then we'll start to bring together some of our ideas. I'm aware that a few of you have just joined. So what I might do is just repeat the invitation. We've got some sticks of two. We've got some sticks of three. We've put some twos together to make six, three twos together to make six. And we've put two threes together to also make six. So one question that occurs to us is, I wonder if there are any other ways of making six. But also more generally, I wonder what other numbers we can make through combinations of twos and threes. I can see some of you are beginning to post some ideas in the chat. You may like to post a number that you have made and let us know how you've made it. Or you may like to post some of the questions that occur to you. So I'll be quiet again now.
And shall I start keeping a record of what people
It
are?
would be great, Charlie, if you could. So just remove those out of the way. Yeah, thank you. Thank you all very much for your contributions so far. Charlie is doing a magnificent job at recording some of the suggestions that are coming in. I'd like you to imagine this was taking place in a classroom. I can picture children perhaps working at tables in twos or threes. They might be finding ways. They might be working with each other, and then at some point you might be suggesting that they pause and you facilitate a sort of a whole group discussion. And at this point, the role of the teacher becomes what Charlie is doing. He's inviting, although we're doing it via the chat, we're inviting suggestions of what you have done so far. So this is very much about what children can do. This is not about what they can't do. What children can do. So what have you done? Charlie, you will notice, is recording in a very particular way. There's a strange gap here, Charlie, which I suspect is rather purposeful. So all this is in mind before the lesson has started. And this way of recording is really helping learners to make sense of what's happening in the classroom and the mathematical ideas that they're being invited to work on. So Charlie, talk me through these boxes that you've added here.
Well, the 2 plus 2 plus 2 is that one there, which made 6. And do I mean that? I don't mean that, do I?
Don't worry.
I've got the colours wrong, don't I?
Unfortunately, you've got the colours the wrong way around. But shall we, if you like, I can make these. Well, actually, if I start making the colours different here, then I think everything we've written on the chat might be.
Right.
Don't worry. Don't worry. Don't worry. Ignore the colour. Why have you put a box around the two?
I'm just going to do that again.
Okay, all right.
And I'm going to have 6 is 2 plus 2 plus 2.
Okay.
And it's also 3 plus 3.
Yeah.
And I will do them. So I did blue last time, so I'm going to do
nice.
The blue there.
So that's your blue.
Which is my, yes, 3 plus 3. Thank you.
That's okay.
And 2 plus 2 plus 2. So I'm just thinking that I know that I can make 6 just using 2s and just using 3s.
So this is a really good opportunity. I'm going to interrupt you already, Charlie. You know that, do you? So as the teacher, I might be saying, how do you know that, Charlie? One of the really nice things about low threshold, high ceiling tasks, I think, is that they offer opportunities all the way through to have these, to be expecting children to reason mathematically as they're working on the task. It's not about doing all the reasoning at the end. So tell me, how do you know that there are only 2 ways of making 6?
I'm not sure I said that there were only 2 ways, but no, but that's okay.
I wasn't listening carefully. That
how
was my
do
fault
I
then.
know there are only 2 ways? Well, an alternative. Okay, so the top one's got 2 sets of 3.
Yep.
And the bottom one's got no sets of 3.
Okay.
So the only way an alternative could be made would be to have 1 set of 3.
That's really nice reasoning. Okay, good.
Phew. And so the alternative would have to have a combination of 3s and 2s. And so if you have at least 1 of each, I'm not going to
You're not going to be able to make the 3 that's missing. Okay, nice.
Oh, okay.
I'm a hard taskmaster.
Okay.
Okay. So the reason that you've boxed these together, Charlie, is to
I'm going to start thinking of them as a useful block because I know that I can transfer 2 3s into 3 2s.
So every time we have 2 3s, actually we could exchange for 3 2s
and get an alternative.
And get another answer.
And likewise the other way. If I've got 3 2s, I can transfer them. So
this might help us in making sure we've got all the solutions potentially, or in generating more solutions.
Yeah, so somebody put two solutions for 10,
Yes.
and I'm looking at, oh, the twos. So three twos. I'm going to think of this as a block,
Hmm.
and I know that that block is the same as this block.
Yes.
So I can create a new solution which doesn't use those three twos and instead uses a couple of threes.
Yeah.
And I'm now convinced that there are only two possibilities because I can't do that again.
No, you've only got two twos left over, if you like. Mm.
Yes, I can't. I need a third two,
Yes.
which is what happens here.
Ah, with the 12.
So here
Mm.
I've got three twos,
Hmm.
which I can replace by two threes.
Yep.
And then I've got still three
Yep. Two
twos,
twos.
so I can then replace that by a couple of threes. So
Yep.
I've got a solution with no threes, a solution with two threes, and a solution with four
Four
threes.
threes. Nice.
And one question we could ask is why can't I have a solution with just one three or three threes?
Nice question. Perhaps should we pause to think about that?
Yes,
Hmm. So why can't we find a solution with one three or three threes?
when we're trying to make a total of 12.
Thank you. Several of you have posted talking about odds or odds and evens. So let's have a think. If we have one three or three threes, that is going to make an odd total because we know that any twos that we also have will make an even total. So we know the twos are going to make an even part. So if we had an odd number of threes to add on to our twos, we're not going to make an even number. And you've talked about that in slightly different ways in the chat. At this point, of course, in the classroom, you may want to do some images. You could be drawing some images of what I might call chocolate boxes. We could even use our cubes as we've got cubes. Thank you, Charlie. Brilliant job. This would be a nice opportunity to reinforce, your what Tim Rowland might call a generic model. So your odd numbers being depicted by rows of pairs and then a single one sticking out.
It doesn't matter how
How
long my
long?
chocolates are,
No, it doesn't matter how many pairs we've got.
but I can see that if I've got two odd numbers, and I can tell that they're odd because there's an odd one out, there's
Yeah,
an odd square. But as soon as I pair a couple,
yeah,
I can see that it'll make a chocolate bar that looks like this.
yeah. And many of you will be using resources in the classroom, teaching resources in the classroom, which offer very nice representation for odd and even numbers. So your children will be familiar with this representation. Um,
So
Charlie.
for the 12,
Mm,
we needed an even number of threes
right.
because an even number of threes would add up to an even
An
total.
even total.
So we could check. That
Hmm.
suggests that for the odd totals, we're going to need an odd
Oh,
number of threes.
okay. Perhaps you could have a little think about that. Hmm. We've got a couple of examples of odd totals, which you've already brought to our attention. Why doesn't everybody try another odd number? See what happens.
What shall we try 13
Okay.
as the
Yeah,
next?
yeah, yeah. In fact, 13 came up on the chat in conversation, I think. Did it? Have I just made that up or did I see it being discussed? Yeah, let's try 13. Any suggestions for ways of making 13? Thank you. Several suggestions coming in here, Charlie. Oh, I'm going to scroll right up here. So we've got a solution here which uses a 3 and 5 twos.
Now, I partly wrote it that way, Liz,
Oh, yes.
because we've done 10 earlier on.
Ah, right. So
So
we
I,
can
I
use
knew I
this.
needed a 3,
Yep.
and then after that, I could just use even numbers. And because I've got 3 plus 10, I think I can now start chunking three twos, and replacing that by
Hmm.
two threes.
Nice.
I've still got the 3 from before.
Yep.
I've still got a couple of twos.
Yep.
I'm not going to be able to do anything with these twos in terms of replacing them.
No.
So I have my 3 that I had at the beginning,
Yep.
and then pairs of 3.
Yes.
So,
So we've got the evenness here.
so I'm going to, so I think if I had to do 23, I would have 3 plus 10 twos.
Uh,
1, 2, 3, 4, 5. I'm finding it difficult to say a number, but write a different number.
Shall I count, or is that going to make it worth?
10. Is
Nice.
that still on the page? Yeah.
It's just about, yes. Great.
And so for any new combination, I'm going to be able to replace that
With two
with
threes.
two threes.
Yep.
And I'm still going to have my 3 at the beginning,
Yep.
plus,
Yep.
well, those could all be twos,
Hmm.
but they could also be another pair of
Another pair of
threes.
threes. So that's right.
Can I write pair of threes as threes? And I could have another
And
pair
you
of
could
threes.
have one more. Yeah,
So that's quite nice
it
because
is.
I've got my odd one out,
Yep. Yep.
and that's going to
That's an
make it
even
even.
number. That's an even number. That's an even number. And the two on the end is going to make it even. Yeah.
You said something earlier, Liz, about the value of tasks like this, offering opportunities to notice what's happening, but then to offer explanations
Yeah. Yeah.
and to expect students to be able to explain what's happening
Yes.
at an early stage.
Yes.
So
Yes.
sometimes we assume that we've got to do all the work and then we come to a result and
And
then
it's only at that point.
we
Yeah.
ask students to explain or
Yeah.
justify. And I think it's really important to try and capture those moments early on,
Yes.
that offer an opportunity for students to explain and justify. Um,
Absolutely.
Partly because you're modeling the kind of questions you want students to ask, but also because you're then encouraging students to have similar conversations when they're working in their small groups, for example.
Absolutely. And to begin as well, I think if you know you drop those questions in as the teacher initially, you're right, then students begin to pick up on those questions and will ask of each other. And eventually it becomes like a little internal monologue, I think. And students will be, even in those situations where perhaps they are working on their own, they're thinking,
And they're asking themselves why? Why is this
asking themselves
happening?
why. Yes,
Um,
yes, yeah.
Sometimes there's the danger otherwise that the highest achievers get to the solution at the end and they're the only ones who get asked to explain anything.
Exactly. That's the risk. If we don't thread the reasoning through, then it's the children who perhaps work more quickly or historically have been higher achieving. You're right.
Yeah.
Yeah. And we want to give that, that's the crux of the webinar. This is mathematics for all. Yeah. Um, we have gone very quickly to working in quite a systematic way here, Charlie, which of course won't happen so quickly, depending on the experience of the children that you might introduce a task like this to. You might be modeling some of that initially, and you might be scaffolding some of that. You, Charlie, have your recording has made that very clear for us and helped us along the way, which is really useful. But we've gone much more quickly than you would in the classroom, of course.
And students might be offering some of these ways of representing what's going on.
Precisely. Precisely. Yeah.
But you and I have worked with classes where the way we lay out things on on the board makes it easier for students to notice.
That's it.
And so
That's it.
I'm choosing to write things in a particular order.
Yeah.
So when there's an even total, I've only written twos to start with and then replaced them. But when there's been an odd number, I've sort of started with the three because I know I need a three and
Yes.
then just had twos. And then I've been able to use what was there before. So
That's right. That's
I'm
right.
saving a little bit of time.
Yeah. Using your thinking from earlier to develop your thinking currently. Yeah, which is, I think mathematicians are inherently lazy in that respect. Efficient, should we call it, rather than lazy.
And you asked at one stage, why was there a gap? But
Yes.
we might ask students, oh, why did Charlie write things in this particular order?
That's it. That's it.
What do they notice about the way that I've written the even numbers and the way that I've written the odd numbers?
Yeah.
So if we want students to be systematic in the future, actually modeling being systematic is really
Is
important.
key. Exactly.
And we might sometimes write things on the board all in a mess and then organize it.
Yeah.
But we've got less time here
Yeah.
and we don't have a very big whiteboard.
No.
We've just got a
Yeah.
sheet of A4. So
That's right. That's right.
I'm slightly anxious about not making too much of a mess and not taking too much time. But in the classroom,
You might be messier to start with.
so
Absolutely.
they can learn that that's fine, and then later on you tidy
That
up.
there's a deliberate step. Yeah, absolutely. And this kind of work, if you're doing this kind of thing on the board, children will have their own questions as well. Something like that, as you have demonstrated, because some of you have posed not just solutions to the questions we posed, but many of you have begun to ask your own questions, and that is exactly the behavior that you'd like students to be I was going to say doing, that's a very clumsy way of phrasing it. That's exactly what you'd like to see in the classroom. And it might be that on occasions maybe you post up a collection of students' questions in a separate bit of the board or a separate flip chart or something, and sometimes you as the teacher might direct perhaps the whole class to be working on a particular question because you can see the fruitfulness of it. So that's quite important. But there are other times when maybe you would want groups of children to be exploring a question of their choice that has come up, and that will depend on your objectives for that particular lesson, what you're particularly wanting to get out of the lesson.
Yes, you don't always know what questions are going to arise.
That's it.
And
That's it.
so,
yeah.
I mean, a question that has just arisen for me.
Go on.
And I'm asking it partly because we're talking about low threshold, high ceiling.
Yeah.
And this is not a question that you could ask all the students, but you might ask some. You've seen how I organized 23.
Mm.
And I think from what I've written, I think I can deduce that there are four different solutions,
Right. Yep.
four different ways of having 23 cubes using just two pairs
Using
of two
twos
and
and
three.
threes. Yes.
Because I can have one three and all
All
twos.
twos. Yep.
I can have three threes
And the
and all
rest twos.
twos.
Yep.
I can have five threes
Yep.
and the rest can be twos.
Yep.
Maybe I should have
Oops.
written a two here.
Oh, yeah,
Or
good. I'm just going to move this slightly over.
or
There
I
we go.
can have seven threes and a
And a
two.
two. Yes.
So um, I haven't had to write it all down.
No,
I
no.
shall be able to.
Yeah.
So my question for everybody, so and this is not a class. In a way, I'd be going around the classroom, I think, possibly having slightly different conversations with
With
every
different.
group or individual that I talk to,
Mhm.
and sort of leave them with a question. At the very beginning of our guidance, we've written that everybody should have an opportunity, should be able, should come to our classrooms and have the experience of succeeding
Yeah.
and have the experience of having to struggle.
Yeah.
So I want to sort of leave every conversation with students having something to think about.
Absolutely.
And let's imagine we've had this conversation
Yes.
with somebody,
Yeah.
and we've deduced that that means that there are four different ways of listing
Hmm.
threes and twos to combining threes and twos to make 23. How many ways are there if we wanted a total of 33?
Oh.
So I just want to pose that and let everybody have a think about it. And of course, you may want to write all the possibilities,
Hmm.
or you may be wanting to be slightly lazy, like I was. Um, It's interesting that this has started as a key stage one kind of activity
Absolutely.
and it's finishing as a end of key stage two kind of
Absolutely.
activity.
Absolutely.
And I think this is what a low threshold high ceiling
See,
task is,
yeah,
that when we're talking to students, there's always the opportunity of finding something interesting to think about
that's right.
when they're finding
Yeah.
what we've been doing too straightforward. Sorry, I keep moving this.
No. Any suggestions of how many ways we think we might be able to make 33? We've got a conjecture from Nikki. I'm using the word conjecture because of the question mark after the sounds. I can imagine somebody phrasing that as a conjecture. We've got some agreement. Thank you very much for your solutions. There seems to be, Charlie, an agreement that there are 6 solutions. Um, People are talking about various ways. So a few people have written quite systematically have written out the solutions.
So I haven't got a solution yet, but that's what I've done so
But this is
far.
a great start.
Okay. So
Yeah.
what have people been doing?
Well, this, I think, what you have done is possibly the reverse in terms of order of Billy's solution here, maybe.
Oh, has people started with all three?
So Billy happens to have started with all threes.
Which means, yeah, much more efficient than me because you only have to write 10 threes and I've had to write a whole load of twos.
Oh, but
So I've got lots of threes.
I think 11.
I was about to write 10. So thank you for
That's okay.
correcting me. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
And then yes. So Billy has done the reverse of what you've done here.
Yeah.
So rather than swapping 3 twos for 2
Yeah.
threes, Billy has taken 2 threes and swapped it for 3 twos. So we've got
So I'm going to be able to swap a couple of threes for a 2.
Yep, the 3 twos. Yep.
Yes. So that would give us a second solution.
That would give
This
us
had no 2s.
correct.
And then we've got one set of 3 2s, 2 set of 3 2s, 3 sets.
4 solutions, 5 solutions, 6
1, 2, 3,
solutions.
4, 5 plus the one
Plus everything, all threes.
Nice.
Nice. Yep, yep, yep.
So
So I think we agree.
you and I talk quite a lot about visualizing and multiple representations.
Yeah.
And this feels like a really useful way of representing what's going on.
Yeah, yeah.
And it means that we can do a lot more because we can see how we can replace a block of 3 2s by a block of 2 3s.
Yes, yes.
And then ask quite hard questions.
Yeah.
Because, you know, we've jumped to 33.
Yes.
And of course, with some people, you might, you know, want to jump further.
Yeah. We had a conversation before this afternoon about how we might introduce this task. And so this is possibly quite a nice moment to mention that because we wondered whether to introduce it as we did or to introduce something quite challenging in as a sort of what's the word, as a hook, knowing that it would be too difficult for students to work systematically. So we could have said something like, I wonder whether we can make 200 out of 2s and 3s. How might we do that? I wonder how many different ways there are of doing it. So that seems an enormously unmanageable task. But sometimes it's quite nice to hook students in with an unmanageable task and then present then tweak the task so you introduce the low threshold instead. Then we can go back to that what was an unmanageable task and have those conversations about, well, now we've done this thinking, actually, that unmanageable task has now become more manageable. So the structure that you have introduced has made that, that task, which sounds scary, actually more manageable.
Yes, I think this morning, before we thought about this problem, if we'd been asked how many different ways of combining 2s and 3s to make a total of 200 would have seemed very challenging.
It would, yeah, absolutely.
But one can then introduce students to the idea that when mathematicians are confronted with a challenge of this sort, they simplify it.
Yeah.
So we're teaching them the value of building on simpler cases.
Absolutely.
And
yeah,
the reason why we thought that it might be interesting to start with 200, because we could then imagine 100 2s.
Yes.
And then you could imagine starting to chunk
Yeah.
3 twos and then
Yes.
6 twos
Yes.
and 9 twos.
Yes. Yeah, like you've done here.
Yeah, until you
Yeah.
got to 99 twos.
Yeah.
And all of a sudden, oh, I must have I must have 33 chunks.
Yeah.
And then
Yeah.
I
But that's only come more easily and fluently having thought of this chunking, having had a
yeah.
go at that chunking. Yeah.
And what would be nice, the reason why it would be nice to introduce students to a really hard problem is to at the end of the lesson say, remember that hard problem we tried? Does it, let's spend the last 10 minutes of the lesson trying to answer it.
Yeah,
And the idea
absolutely.
that to reinforce the idea that students
Mm,
arrived in the lesson not being able to do something and they can now do
mm,
something that seemed very
mm.
difficult feels like a really positive experience for students.
Absolutely, absolutely. Thank you to you all, because as we have been talking there, I can see that some of you have been posting other ways of thinking about the solution to 33. You've also been posting some of your own questions that you've been having, and which shows that, yeah, which is delightful. We didn't really focus on any patterns in the number of ways, but that's something else we could have done. Could we predict some numbers of ways? We thought, with the 23 to the 33, you were beginning to delve at that, Charlie, but perhaps we could think more generally, um, could we be predicting, can we predict the total number of ways of making numbers? Is there a discernible pattern there if we worked systematically in I was going to say chronological order. What do I mean?
So,
Numerical order. Yeah, or ascending order. Thank you.
would you want everyone to work on one?
No, I think we probably, it's 4:45. I think we possibly
Okay.
need to
Okay,
do,
well, let's give everyone a chance to take away some homework.
yes,
We
so there you
think
go.
there is a pattern. We think you can predict how many ways there are when your total is a multiple of six.
Yes,
So,
that's something to
um,
think about.
yeah, so we had six here at the top earlier, and we've got 12, and the next one to try would be 18 and
18.
24. And I th th there is a pattern which I think can be
Explain. Yeah,
I think it's really
absolutely.
important to
Oh,
do
definitely.
activities
Yeah.
with students where they might notice something, but then there is an explanation.
Yes. This is
It,
not this is not chance that there's a pattern. It's not magic. There is a mathematical explanation. I agree.
yeah, because
Um,
I suppose in the end, whether student if students leave the class,
mm,
sorry, knowing that there are they don't need to know that there are four ways
of
of
course not.
writing 23
No.
in as a combination of two three. I
No.
mean, the final results of these is not important.
Right.
What I want them to take away at the end
Mm.
is a way of thinking,
Yep.
a way of playing with numbers.
Yep.
The fact that our teacher turned up with some cubes and asked, and was curious
Mm.
about and asked us a question that got us hooked and
Mm.
engaged, that maths is a subject that does get us hooked and engaged,
Yeah.
that does provoke new questions, and that actually feels quite satisfying
Mm.
when you notice patterns and you can build on them and
Mm.
you can explain why
Mm.
they happen.
Mm.
I, I want my students to leave my lesson feeling that they've worked like mathematicians for an hour. And I
Absolutely.
want them to feel that, oh, I'm looking forward to coming to
See? Mr.
Mr.
Gilderdale's
Mr.
learning.
Wooden's
That's it.
classes
Yep.
again. And
Yeah.
I also want them to feel positive about their experience of learning math.
Yeah.
So I don't want it just to be some students who succeed and some who only ever experience failure. I want everybody to have the opportunity to experience success and everybody to also experience not so much failure, but struggle.
Getting stuck. Yeah.
Getting stuck and
Yeah.
struggling is part of being a mathematician.
Right.
And so I, I want my student. Okay, I'll be quiet now.
Thanks, Charlie. So, I'm going to stop sharing the Oops, no, let me not do that. Oh, rubbish. What have I done? There we go. I'm going to stop sharing the visualizer. I'm going to attempt to stop sharing the visualizer. There we go. Managed it. Let's just have a quick reflection. I want to show you on the NRICH site where you can find the guidance and where the recordings will go. You've talked very eloquently there, Charlie, about the purpose of our tasks in terms of nurturing young mathematicians. You yourselves, you may have, as we've been working, you've been maybe thinking about some of the sort of the characteristics of that task we worked on. Absolutely key, I think, and you've touched on it, Charlie, is that starting point, that really simple starting point that everybody can engage with. We're talking, whole classes, so that's absolutely key. But I hope what you will have taken away from what Charlie has said as well, that that allow that there it's more than just the task. So the way of working with the task, John Mason, who is somebody who we very much respect, whose ideas we very much respect in maths education, he talks about rich tasks, and he says it's not the task itself that's rich, it's whether a teacher is using it richly, and I think that is absolutely spot on. So let's have a little look at our let's go to the NRICH website. I'm just making sure that I've got it. Yep, okay. We'll share the web browser. Here we go. So we've got the home page here of NRICH. Now, we have chosen just one task to give you a flavour, depending on the age of experience of your pupils. I'd like to think that, all primary pupils would get something out of that task. However, don't forget that if you go to our primary teacher homepage, you click on the curriculum linked problems and select our curriculum mapping, you will find a whole host of tasks here. Now, we cannot promise that all of the tasks on the mapping documents are low threshold tasks. They're all rich mathematical tasks. They are not necessarily low threshold, high ceiling tasks. We are working towards that, but many of them are. So do remember that you can introduce children to these curriculum concepts which are part of your mathematics teaching through a low threshold, high ceiling task. So don't forget that. Let me show you the guidance page that we have created. I'll pop the link in the chat. You will get this sent to you as well via email. An automatic email will come, which will remind you of that after the webinar, possibly tomorrow morning when it's scheduled. So in our guidance, what we've done is we've just outlined briefly this idea that Charlie has mentioned, everybody in mathematics has the right to succeed and has the right to struggle. And low threshold, high ceiling tasks and pedagogy really support that. We've listed there a few characteristics of rich tasks. Obviously, a particular task may not have all those characteristics, but I also wanted to draw your attention to the fact that we've recently been developing what we're sort of thinking of is some guidance, some general guidance about using NRICH tasks. So helping you to get a picture of what a low threshold, high ceiling classroom looks like. So there's a link here near the bottom of the low threshold, high ceiling article, which takes you to this page, which is a new page on the site. We will be tweaking it a little bit in the coming weeks, but it's not going to change much now. Our intention is, alongside some of the specific guidance that you'll find in the teacher's resources of each task, this offers some general guidance about how we envisage our tasks being used in the classroom. So we do hope that is useful. I'd also like to mention that if we go to the bottom of the low threshold, high ceiling guidance page that I've just mentioned, there are two more articles which were developed a little while ago on NRICH, which are really useful for more reading. If this is an idea that you've not come across before, do take a look at these articles. The first one offers a little bit more guidance on what we mean by low threshold, high ceiling, and then the second one is much more about the pedagogy. I'm just going to click on that second article because I'd like to also show you that towards the bottom of that, we've purposely sort of put links at the bottom to a selection of tasks at different age groups. Now, as I said, many of the tasks on our mapping document are low threshold, high ceiling, but we've pulled out some here, which are, will offer you a good example of low threshold, high ceiling tasks if you've not tried this way of working before. Charlie, what have I forgotten? Is there anything that we meant to mention which I haven't done?
I can't think of anything.
Okay.
We've mentioned that a link to this page will be sent when the
Yes.
video recordings
Yes.
are all ready.
Oh, actually, what I didn't, yes, I didn't specifically say that actually, that if I go back to the guidance page that we've written, the recordings will go at the top of this page. Thank you. I hadn't specifically said that. I'm just posting now a link in the chat to a Google feedback form. We'd really appreciate your feedback, please. Obviously, it helps us do a better job, and it also gives us information to share with our funders, Trinity College. Thank you. I think we've we've come to the end, but Charlie, have you thought of?
Okay, I suppose I'm looking back at what we did,
Yeah,
and it seems to me we went in a fairly straight line
we did,
through
didn't we? Yeah.
this problem. And sometimes we talk about low threshold, high ceiling, wide walls.
Yes.
And
Good point. Mitch Resnick, that's his.
right,
Yeah.
so I mean, we focused, and I mean, partly because of time, only on twos and threes.
Yes.
But another way of extending and broadening this problem
Good point.
would be to start thinking about, well, can you predict what's happening if instead of twos and threes, Liz had found threes and fives
Yeah.
in her cupboard,
Yeah.
or threes and fours in her cupboard? And fours and sixes. How are you going to make seven? How are you going to make 27? Oh, all of a sudden, some things are impossible.
Mm.
Um, if you just have odd numbers and you're only allowed an even number, there are other ways.
Yes.
What happens if Liz had two threes and fours, or two threes and fives, or
Yeah.
two threes and sevens instead? Um, so one can do quite a lot
Yeah.
beyond. We stuck
You're
to
right. We have done sort of quite a narrow journey, haven't we?
and
Yeah.
ended up doing quite difficult,
Yeah.
the 33, for example,
Yes.
without having to write it all out.
Yes. Yeah.
But we could have also um, suggested other
Yeah.
questions,
Thank you.
or
That's useful.
students could have suggested other questions.
Yes. Yes.
Um,
Yeah.
and in some classrooms, different groups of students end up working on different questions, sort of, which have all had the initial springboard, but then it's really important that they make it very clear what their question is.
Yes.
And um, and then the teacher has slightly different conversations.
Yeah.
And the feedback is displaying their work becomes really much more interesting because everybody's possibly displaying their answers to slightly different questions.
Yes.
Where sometimes in classroom displays it's a bit boring because everybody's got the same answer, everybody's used the same representation, everybody's sort of found the same, except they've used sort of different colours. But all of a sudden, when they're working on slightly different
Something
questions,
slightly different.
then
Yeah.
the findings are
Yeah. But you've had that link at the beginning, and so everybody can still take part in the conversations, which is key, isn't it?
yes.
And yeah.
And we particularly like this because you just started with a pair of cubes, some
Twos and
cubes.
threes.
Yes.
Right. Thanks, Charlie.
Right.
Thank you all very much.
Me believing on. It's taken us to 5 o'clock.
It's 5 o'clock. So we will say thank you and goodbye. We do look forward to seeing you at a future webinar. Do keep your eye on our events page to find out more. Thank you very much indeed. I might just post the feedback link one more time, just in case.
Actually, I could say one other thing.
Go on then, Charlie.
If any of you teach top of Key Stage 2 and want to know how you can start a low threshold, high ceiling task on averages come to our webinar tomorrow,
Yeah.
where we're going to be working with secondary school teachers,
Mhm.
but on a problem that, at least at the start,
Has an accessible starting point.
is accessible to year six students.
Absolutely. You'd be very welcome.
Yeah.
Thank you, Barbara. Thank you so much, all of you. Have a good rest of the evening, and we hope to see you again in the future.